So good evening, everyone. Myself Jimmy, and today we will discuss week three's content, which is k-means clustering. So till now, you in week one and two, you basically discussed PCA, which is one of the unsupervised algorithm. Okay. Basically, where what we usually do is that using PCA, we just extract the features, extract important features from the available data set. Okay, so that's the job of PCA. Okay, and in week three, we are discussing one new unsupervised algorithm, which is k-means clustering. Okay, so basically, what you see, let's talk about some real world example of k-means clustering. Or okay, can some of you give some example where we can use k-means clustering? I mean, whoever has some idea, they can talk.
Sir, your
Anyone?
profile.
Yeah, yeah. Someone was saying something.
Yeah, I was saying your profile picture is an example of k-means cluster.
Yeah, that also you can see. Yeah, that is also okay. Yeah, that is also one of the example of k-means clustering, and actually it is also example of SVM also. Okay, SVM classifier. Okay, okay. Yeah, that is also example of k-means clustering. Okay, Netflix movie recommendation. Okay, uh, here you yeah, it's like extension of yeah clustering. There also like we use clustering, and then yeah, after that yeah we do the recommendation. So recommended system, that is also, I mean, that is another topic. Okay, but yeah, there also like we use it. Any other example anyone would like to say?
To group the data, sir, whichever.
Okay, to group the data. Yeah, that is the, I mean, see, that is the job of k-means clustering. It as the name says, but a real life example, maybe where you can see. I mean, since you have already gone through the lectures, then I assume that you would have idea like what k-means clustering does. Okay, so that's why I'm asking uh, where you will use this k-means clustering. I mean, any example till now what you have got. Okay, so okay, let me change my question first. Okay, so what do you understand by k-means clustering? What is the job of k-means clustering algorithm?
Even students'
Segregation of
marks,
data.
I mean, assigning grades to the students.
Not really. Okay, just go one by one. Okay, then I'll be able to hear all of you. Okay, Sathi Anand, yeah, just
Yeah, it can be used for grading the for students like A, B, C, D.
okay, okay, just give me something. Okay, sorry. Hello.
Yeah,
Yeah, you were saying.
yeah, we can use this for grading the student. We can classify them in different buckets like A, B, C, D. Yes.
Okay, ABCD S. Okay, yeah. Okay, yeah. Anyone? So I am asking like what k-means algorithm does. Okay, so that is the answer. I mean, I'll again come to this question. Okay. So I mean, I have changed my question. So my first question is like, what is the job of k-means algorithm?
Grouping the similar data.
Grouping the similar data. Okay. Exactly. Anyone else would like to add or subtract something here? Anyone?
Clustering is the set.
Yeah. I think the same thing. Whatever you guys are saying, no, exactly that only. Okay. So basically, what you are doing here, you are just adding something. I mean, yeah, you are just grouping the data. Okay, whatever data available to your model, you are just grouping it into different clusters. Okay. Yeah. So first question is this one. Okay. So I mean, I was asking about the real world example of clustering. Okay, where you will use cluster. Okay. So someone was saying that I mean, You will use clustering to group the results. I mean, people who got A, people who got B, people who got C. Okay. So is it directly? I mean, so what would be your statement? What would you say? Using K-means clustering, what will you do? You will group the student. Is it? Hello.
Yes, yes, yeah.
Yeah. I mean, into different grades. But that you can directly do, no? Let's say people has A grade, people has B grade, people has C grade. You can directly, I mean, group them, no?
Uh, yeah, but if you want to decide actually on the criteria, then we can use this now.
So what type of criteria? See, I mean, see, ultimately the K-means is nothing but the grouping. Okay. So here also like we have group. So yeah, grouping the data based on similar properties. Yeah, exactly. Okay. Based on similar properties. Okay. Let's say here, I mean, if you want to give them, I'm grade. So let's say you don't have their exact marks. Okay. Let's take this example only. So you, what happened? No, I mean, you got some students. Like let's say you have 20 students, and you have to predict like you have 5 groups. Okay. I mean that this also like you have to decide. Like I mean, any students will fall in which group? How will you decide? You can have different criteria to decide that. Okay. Or your model could have different criteria to decide that. Okay. So basically, the first and foremost criteria is that for K-means clustering, you use unlabeled data. Okay. What I am trying to, I mean, convey you is that so for K-means clustering, you use unlabeled data. There are no labels on that data. Are you getting my point? I mean, at least your algorithm doesn't understand that. I mean, they
Yes, yes.
whether whether some label is there or not. Let's say you are talking about this, I mean grade only. Let's say you have a data set, okay, where you have students age, students marks in some subject, I mean maybe or maybe I mean you have rated student like very good, their attendance, maybe other performance, okay, performance in some olympiad or something like that. All these things you have, and now I have given you the, I mean, now we have given this data set to the K-means clustering algorithm. What K-means clustering algorithm will do? No, it will try to identify some pattern in the data. Okay, and maybe some similarity or some pattern it will find, and based on that, it will try to group them. Okay, it will try to group them into different clusters, and this is the cluster. I mean, it may happen that I mean, so K-means clustering doesn't understand whether this, I mean, clustering happened, I mean, based on their marks or whatever. Okay, we gave some features to K-means clustering algorithm, and based on that, based on certain similarity, it just created different groups. Okay, and again, one more thing. Here, K-means algorithm also doesn't know how many groups they have to create. This is also you have to tell the K-means algorithm like how many groups they have to create. Okay. Any issues here or anything? I mean, hello. At least interact. If you guys will interact, then I will be able to open up myself.
Yes, sir.
Okay.
I mean,
Yeah.
I said that grouping the data according to the grades. So that means if we are labeling the data, the above 90 it's A grade, above 80 it's
Yeah.
A
Yeah.
grade. So, but K means is only used for unlabeled data.
Yeah.
Whenever
Exactly.
we want to use for unlabeled groups, then we have to use K means. Is that right, sir?
Right. Right. Exactly. So
Okay.
basically, yeah, you are not saying K-means algorithm that you we here you have A grade, S grade, B grade, C grade. You just
Yes.
gave some data set. Okay. Now
Yes.
let the algorithm decide. Okay,
Yeah,
how
yeah.
they want to,
Because we
yeah,
have to give
build,
only the number of students. Then
yeah,
we ask the K means algorithm to divide into groups.
yeah, number of
Yes.
students and their different properties. Maybe there are
Okay.
different properties. Yeah, okay. Whatever properties you want to give, you can give. You ideally, what happens? No, there are different features. Okay, I mean maybe I mean 10 or 20 features. For example, here we are saying that yeah, students' age, students, I mean height, students' gender, students, I mean attendance, all these things.
Yes,
Okay,
sir. Yes, sir.
if you
Yes, sir.
take, yeah, if you take their, I mean this one only as a, let's say you can also say that the student's grade. Okay, if you take that, then maybe this is also, this can also be yeah, it identifies some pattern, then put them into different group based on similar pattern. Yeah, basically here you can say similar properties. Okay, I mean similar score or similar number, whatever you say. Okay,
Sir, but basically it will find the mean and it will adjust the data points near to the means. So it will not group anything similar to the properties, no, sir.
see what happens. No, let's say maybe here we are talking. Let's say I mean there is a data set. Okay,
Yes,
here
sir.
I mean yeah, and that data set is just one only one feature. That is I mean male and female. Okay, gender.
Okay,
Okay,
sir.
we gave this as an input to k-means clustering algorithm. We didn't say that here is a male or here is female. Something nothing like that we said. Okay,
Okay,
it
okay.
now it is k-means clustering algorithm. Like it will find similarity. Like let's say, I mean sample one is male, sample two is male, sample three is female. Okay,
Yes, sir.
then
Okay.
I mean once yeah. Okay, so it will see that whether these are similar thing or not. Okay, based on that it will
Means
create cluster.
we have to specify male and female. That is the similar properties.
Yeah, yeah. So I mean, male. Obviously, I see machine doesn't understand text. Okay.
Yes, sir.
Anywhere like a machine understand numbers. So once you before applying the K-means clustering algorithm to this one, you have to either yeah both thing you can do. Even if you give this text no, it will cluster. Okay, it will see that male, male, male. This is a one column. I mean one cluster and female, female, female. This is another cluster.
Another cluster.
Okay.
Okay, sir.
Yeah. So it just finds some pattern, I mean, some properties or maybe similarities, and based on that, it creates cluster around that one.
Got it, sir. Got it.
Okay. Yeah, that is, I mean, the some real world example of what I give. Okay. Similar, I mean, this type of case where can happen? Okay, just try to find out. Okay, maybe if I modify that grade pattern, no, I mean, what we can say about that grade example, grade example. Let's say your data set, you are giving your model as a data set where you have given them, I mean, their marks. Okay, and now I mean let the you said that divide them into five groups. Okay, this also you have to say. Then k-means will find the some pattern. What I mean, obviously the pattern is something like the marks close to 100, marks close to 90, or something like that. So k-means will create five cluster or six cluster, whatever the number of cluster you will say. But it is not saying that this is the grade or something like that. Okay, it is you who are saying that yeah, okay, this we will name this cluster as as we will name this cluster as grade A, grade B, something like that. But k-means clustering does not do that part. Okay, its job is to group them based on some similarity. Okay, yeah. So basically, where you can use these things, maybe let's say image segmentation. Okay, uh, image segmentation, anomaly detection. Do you understand like what is anomaly detection or what is image segmentation?
No, sir.
Okay, okay, just give this. Actually, I'm getting call again. Yeah, sorry. Yeah. So image segmentation. So basically, let's say you have a different images. Okay. Let's say basically, okay, you have given. I mean, your maybe your data set has like 100 pictures. Okay, 100 pictures, and those pictures are maybe related to you can say cat, dog, different animals. Okay, now what you have done thousand okay maybe three things can be only there, let's assume here cat, dog, and or maybe cat, dog, or any animal. Okay, okay, so what will happen? Okay, cat, dog, rabbit. Okay, let's take it. Okay, so what will happen? No, here you gave your model this data set. Okay, where you have 100 pictures. Okay, so what your model will do? No, it will try to segment it. I mean, here also, like even you don't know like how many animals are there in that, how many animals examples are pictures are there in the data set. I mean, in the sample. Okay. So what you are doing here, you are giving that as input. So now your clustering algorithm will, let's say, as I said, you have to decide like how many segmentation you want to do. Okay. So basically, let's say we are talking like we are going to segment it into two parts. Okay. Then it will try to segment all the pictures into two parts. Okay. Based on some similarities. Even we don't know like what it would be the similarity. Okay. So based on some some similar properties it will find, maybe some ears, I mean maybe ears, or I mean shape of a face, anything. Okay. Number of legs, whatever the properties, I mean it find, whatever the pattern it finds, based on that it will create the cluster. Okay. So that's basically image segmentation is nothing but just separating images into different groups. That is image segmentation. Anomaly detection is nothing but, I mean, let's say you have 100 pictures. Okay. All pictures are similar, or I think some abnormal thing you saw. Okay. So that we call as an anomaly detection. Okay. So all these things are an example of k-means clustering. Let's say, okay, lag differencing, spam or non-spam. Okay, yeah, that is not in a nominal detection. That is actually it's an example of classification problem and imbalanced data set. Okay, because see, anomaly is here also, like you see spam and non-spam mails. There are some good proportion of the non-spam mails also. I mean spam mails also. Okay, this ratio is see what is happening. No, let's say if your data set has 50-50 chances. Okay, I mean 50 good, 50 bad, then it's a normal data set, normal classification part. But yeah, let's say you have a data set like 80% one group, 20% another group, or 10% another group. This one you can consider as an imbalanced data set, imbalanced classification data set. And there can be one more, yeah, market segmentation based on certain criteria. Right, right, right. Okay, and there can be third case where, let's say, like once in a lakh, once in 2 lakh, or I mean very small. Uh, at least you have to identify just one piece, something like that. Every single piece is important. Okay, that you can consider inside this anomaly detection part. Okay, maybe you can consider spam or non-spam also. Okay,
Sir, can you
but yeah,
write it in the whiteboard, sir?
okay, okay, that will also work.
Because
Okay.
continuously, if we are talking
Yeah,
something.
yeah, I understand. I understand.
Thank you, sir.
Yeah. So, okay, I think it would. Okay, I hope it is visible now. Hello.
Yes, it is visible.
Yes, sir.
Okay, okay, okay. Yeah. So basically, we were talking about the different examples where we can, I mean, the different sectors where we can use k-means clustering. Okay. Uh, what we are saying, yeah, maybe the images were there, which were like different type of images. Let's take an example, one more example. Maybe I'll give this one is the last one. Let's say what k-means is doing. Let's say you have a box. Okay, this box and different ball you have inside this one. Okay, red, few red balls, few green balls, and maybe few black balls also. Okay, so what is the job of k-means clustering algorithm? What do you think? I mean, so take this example here. K-means clustering does not know whether it's a red, green, or yellow, black. It doesn't understand it. Okay, so what k-means clustering will do? It will create different cluster. I mean, somehow it will find the pattern by their color, by their size, or something like that. Okay, that these all these things belongs to one group. This green one belongs to another group, and this black one belongs to another group. Okay, somehow it will find it. Okay, that is the job of k-means clustering algorithm. Okay, it will create cluster based on their properties. Okay, so yeah, that was about k-means clustering. Okay, and example, let's say someone said that recommended system, movie recommendation system. Okay, here what happens? No, let's say you gave some movie's name. Okay, maybe based on their review or based on their, I mean, director name or actor name or whatever the criteria you have. Based on that, it will create some clusters. Okay, some group of movies. Okay, maybe okay. There are three groups it created. So there are very high. So if two movies are there in this box, no. So there are high probability that there would be very a good amount of similarity between these two movies. Okay, I mean the logic does even we don't know like what was the logic here, but definitely I mean if two movies belong to the same category, no, I mean same cluster, then there would be similarity between these two movies. Okay, maybe see if you it depends like what type of similarity it has. It completely depends on the data set you have given. Okay, the features. What are the features in your data set? Maybe if your data set has only two features, let's say actors and directors. Okay, let's say these two features only. So there are very high chances that the movies which are falling inside this cluster, no, they have the same actor or same actor. Okay, so something like that. And if let's say instead of this, you had an input as your type of movie or genre. Okay, action, drama, comedy. Okay, then your dataset will create these cluster based on these things. Okay, usually all these things are the input to your dataset. Okay, based on these things, it creates the clusters. And let's say what happens, no, cluster A, cluster B, cluster C. Okay, it segments movie into three parts. Let's say here we are assuming that we have clustered it into the three parts. Some person came, okay, person, let's say ABCD came, and he watched some movie. He searched for some movies which belongs to a cluster A. So what I mean, Netflix or other website will do, no, it will recommend them another movie which is also belongs to this cluster A only. Okay, so there can be some one more column like ratings. Okay, everything. Okay, and it's not like they will create just three cluster only. It depends on you, like how many cluster you want to create. As you know, what will happen if you create more number of cluster and maximum how many cluster you can create? What do you think?
A number of data points.
Number of data points. Right, right. Anyone has any confusion in this one? I mean, what he said. Let's say you have a sample of, I mean, you have 100 samples, and I am asking how many cluster you can create. Anyone else? I mean, anyone whoever answered right now, just any other person can say.
100.
That is depend on us, no, sir. Because, our wish,
Yeah,
no. We can
yeah,
create as many as.
Maximum can be
yeah,
100.
yeah. But I was asking like maximum.
Maximum can be 100.
Maximum is
Yeah,
100.
Can be said number of data points.
Yeah,
yeah,
K is equal to n.
yeah,
K is equal to n.
yeah. So maximum number of a cluster can be n only, like then how many data points we have. Okay. So basically, what is the maximum? Worst case, we are assuming that let's say like all the data points belongs to different cluster. Okay, all data points has its own cluster. Okay, this is the worst case. Okay, because now basically you are saying you did very hard work, but basically you didn't do anything. Okay, I mean there are no similarities. No, I mean assume that every data point is unique. Okay, so that's the thing. So basically, what we have to do, no, so why we are grouping it so that we can our target will be to minimize the number of groups. Minimize the number of groups. Minimize number of groups. Okay. But again, you will say this if this is our target, then we will put all the points in one large cluster, right? Like this cluster, you can assume that all the points are inside this cluster. Okay. So what will happen here? I mean, you let's say you created this large group of cluster. So basically, what will happen here? No, here also like you did nothing. Okay, will it be helpful? And basically, you are saying all belongs to the same cluster. Then, what type of work you did? Every algorithm's job is to make the life easier. Okay, so but again, here if you take the maximum number of cluster, and this is the minimum number of cluster. So minimum is 1, maximum is n. Okay, both are not good. Basically, you want to try to shift in this direction so that I mean you get the optimum number of cluster. Okay, I mean here did you got this point, like why we need optimum number of cluster?
Yes, sir, got it.
Anyone? Yeah. Okay, so that's the thing. So always you will try to get the optimum number of cluster. Okay, again there are some rules related to this, like how will you decide like how many clusters you should take. But one thing I would say clearly, in the real world cases, no, there are no rules. I mean, there are no rules. I mean, by which you can say that, yeah, exactly this will be the best number of clusters. Okay, this is always will be the point of discussion. Here, let's say we were talking about this one grades. Here, you know, now I mean, always that there are 5 grades, or I think 6. Okay, S, A, B, C, D, E. 6 grades are there. Okay, that you know. Okay, so by I mean, so you can give them that like create 6 categories. Okay, but there are cases. I mean, if you say that create 3 cases, that also your algorithm can do. But in real world, what happens? No, here to create 6 categories, it was very easy because you had just one feature named as grade. But in case like we were talking about movies, no, you had actor's name, you have director's name, other cast's name, producer, who is I mean cameraman, what is the genre of the movie, like what is the length of the movie, okay, rating of the movie, all these things are there. So when you will work on these type of data set, no, there are no, I mean, rules, or I mean, there are no ways by which you can say that this will be the best number of clusters. What you see here, and so you just see the scores. Okay, maybe by scores, you there will be okay. I think that is there in the slides. So I think, yeah, I'll discuss it. Okay. So obviously, why what I'm till now what I have tried to say, that what is k-means clustering, which is nothing but just create groups based on some similarities. Okay. Then again we said that I mean the number of groups, how many number of groups you have to create. I mean it depends on you. You have to decide it. Okay, and that is very crucial part. Okay, so this tool will work only when you will give input that, yeah, you have to create 5 groups. Then it will identify some pattern and create 5 groups. But this algorithm does not have capability to decide how many groups it has to create. Okay, so till now we have discussed these things, and maybe yeah, we discussed few examples which is related to k-means clustering, where you can apply k-means clustering. Okay. Okay, I'll let me open the slides. Okay. Uh,
So, are there any like fixed parameters which could help us to identify the number of clusters?
there are different methods, but as I said, you know, even in PCA also, like there are no rules. I mean, how many PC? I mean, where you should apply? Where you should apply, that you have to decide, and how many number of components you have to take in your model. Okay, how many number of components you have to take finally. There is no rules by which you can say that. Okay. So here also, like, there are, I mean, different methods are there. Like maybe at the end of this slide, we will discuss the elbow method, and there are still hot scores. All these things are there. But as I said, it completely depends on you. Okay, you will see. I mean, what you have to do. No, let's say you will try out 10. Let's say let's say you started trying from number of cluster 2 to number of cluster 10, and you saw like where your model is giving you I mean, where your model is producing some better result. Okay, or maybe the best result out of 2 to 10, where your model is performing the best result. So you will come up at some point where your model, at least between 2 to 10, where your model is giving you the best results. Okay, it is very easy to find. Okay, I mean, between 2 to 10. But let's say you have, especially in case of images, there can be let's say 100 or thousands of features. Okay, so what you have to do now, how many number of k values, what values of k you will try, that depends on you. Okay, so, and I mean, it is like computation time. It depends also on the computation time, how much computation time it takes. Okay, based on all these things, see, as you increase the size of k, computation time will also increase. Okay, because you understand, no? I mean, creating one bigger cluster is easier than creating two cluster, or let's say like creating one cluster is very easier than creating 10 cluster, something like that. Okay, so that's the thing. Yeah. So, okay. Again, let's say now whatever I talked, that was like from practical perspective. Like these things you will learn in MLP, and yeah, in future you will learn it. Now let's talk about the mathematical aspects of all these things. So whatever now we will talk now, I mean, all these things are just conversion of whatever we discussed. It is just conversion of these things into the numbers. Okay, into the mathematical terms. Nothing more than that. Whatever we discussed, so this was the crunch of like a week 3. Okay, or sorry, crux of the week 3. Okay, yeah. So again, here we are seeing. So basically here, like earlier we said, right? Yeah, these are the data points, and in real world we said that, yeah, the samples. I mean, different features and samples. Okay. Here we are saying that our goal is to partition the data set into k different partitions. Okay. So how many configurations are possible? So that you already said. Okay, which partition is better? We need a metric to quantify the goodness of the partition. Okay, definitely. I mean, how will you decide like whether you have to take the 5 cluster or 10 cluster? Okay, so for that, I think, yeah, we will discuss at the end. Okay, we will show you basically how you decide the. Okay, let's talk that here only. Okay, how will you decide like how many cluster you should take? Anyone? Since you have already gone through the lecture, then I think, yeah, I can ask these things also. Anyone would like to say?
So what is the question?
How would you decide, I mean, whether the, let's say, k equal to 5 is best or k equal to 10 is best?
Not too large and not too small, sir.
Yeah, that is okay. But
It is
let's say like
dependent on the objective score plus penalty.
objective scores. So yeah, okay. If you talk about that also, like what is your objective score? What is your penalty then? Let's say I am saying here, okay, basically, obviously the objective score. So what I am saying, no, what is the metric? Okay, so yeah, you said that that matrix component is score, and yeah, your penalty. Okay, that is true. Okay, so now I am talking about the, I mean the real formula or a real exam, something. I mean, maybe some improved answer that I can say. In 2D, why I'm plotting 2D? Because it's easy to visualize it. Okay, nothing else. Okay, so, yeah, I would have. Okay. So yeah, here let's talk here. Okay. So what do you think? What would be the best K? Anyone?
K is
3.
equal to 3, sir.
K equal to 3. Okay. So how did you decide this?
We were able to
Based
measure
on the
it.
groups.
So how you did you see?
Based on the data.
So okay. How did you feel that this one is the? I mean, this one belongs to another group. This one belongs to another group. This one belongs to another group.
They're
I
close
can
to
see.
Based on the
I can.
distance between points.
Features.
I can create like this, no? I
Yeah,
mean,
we
I
can.
created
It
two
is for
groups.
Based on
green
the
and black
but
nature.
it
color.
has empty space.
Empty space. Here you are thinking. Okay, let's take it. Okay, I'll if I put it more closer, then will you say that it's a two group only? If I let's say I'll just decrease this space, or maybe I'll just push this one at I mean very far from here. Basically, more or less like all of you are in the same place only. It's just about the rewording of things. So basically, distance of
Yeah.
your centroids. Okay, definitely k equal to 2 also can work. But when you will see, no, when you take the k equal to 2, there are two terms like the distance between the part. So what happens, you know, what we do, we create different groups. Okay, I mean the whatever the number of groups you created, and you calculate the let's say if this is a group, no, this is let's say, okay, I think should first take the number of groups as b undo option. I don't know where. Yeah, sorry, someone was saying. I'm just trying to look for the undo option, but I think yeah, this one does not have undo option. Okay, all right. Let's say currently I have plotted here just two groups. Okay, so what will happen here? No, if you this if you, we have just two groups, no, and these are the their centers. Obviously, these will be the your centroid or whatever you say, centroid or cluster mean. Okay, so these are your centroid or cluster mean. Okay, when you calculate the distances of all the points inside this circle, I mean inside this cluster from their center mean, and also like all the distance, all the different points distance from its cluster. Okay, at the intra level, and then again you will calculate how far it is from one another. Okay, both centroids. Okay, or maybe yeah, what happens? No, here you calculate the distance from its own centroid. This should be as minimum as possible, and the distance from the here to this one, this should be as far as possible. Okay, so here I mean yeah, definitely I mean I'll discuss this in the last slides. Okay, but again I mean at the beginning we can say that it depends the distance. Okay, okay, distance from its one point and distance from its I mean the point like the closest point to this. What happens? No, what happens? So basically, you create. Let's say you had these two clusters. So if for any point, you create you calculate its distance. I mean, its distance from this one. I mean, its own cluster, and also the distance from the like a nearby point of this another cluster. This you calculate, and based on this, we come up with a metric which can quantify, okay, whether our partition is good, I mean the best partition or not. Okay, so that's the way. And another, I mean yeah, you have the ways like elbow
So the
method.
answer to this question is based on distance between from the centroids.
And yeah, you can use
And
that this one,
we should
but
choose the
yeah
minimum
we
distance.
yeah, sorry,
And we should choose the minimum distance
yeah,
from the
minimum
centroid.
distance, yeah, from centroid. And also we so there are different ways. Okay, again there are a lot of ways to do this. I mean different methods has come to quantify the goodness of your number of algorithms you number of clusters you have chosen. So some method just focuses on this distance, some method focuses on give weightage to both one. Okay, and there are different methods. Okay,
Okay.
that we will discuss later. Okay, but yeah, definitely what you have to understand here is that yeah, distance is the best criteria. Okay, just use this word distance. Okay, for now. Yeah,
So
maybe
we
after
use
2 hours.
combination of distance square, right?
Yeah, definitely. I mean, always see what happens. No, what you see L2. Always we calculate the L2 square, because like L2 is the distance is nothing but x square minus x2 minus x1 square plus y2 minus y, something like this. No, so just when we do this square, no, this root gets removed. So it's easy to calculate. Okay. Yeah. Okay. So for this one, okay. Now let's talk about. Let's come to this slide. Okay. Okay. So basically, what we have to do, our job was again whatever we said, as I am telling you. So already we have in first 5-10 minutes we have discussed all these things in the example of with practical example. Now we are just discussing it with some mathematical words. I mean, just with the mathematical words and mathematical uh, concepts. Okay. Okay, see. So what? So till now, what do you think? What do you think? I mean, so we need some algorithm. Okay, which can cluster your data set. So here is the Lloyd's algorithm. We call it as a Lloyd's algorithm or K-means algorithm. What it does, its task is to partition the data set into k number of clusters. Okay, and so let's say currently you don't have any, obviously you don't have idea like how many clusters are the optimum number of clusters. So you try to, what you do know, you just randomly, I mean, you start trying from, let's say from 2 to 10. Okay. Uh, you will try all number of cluster. First you take the 2 cluster, then you will take 3 cluster, then you will take 4 cluster, then you will take 5, 6, like this. You will take all clusters and see what is the value you are getting. Okay. So yeah, you will see all the values. You will try all the values of k and see like what is the score improvement happening. Okay, so that's the thing. So what happens? So okay, let's see how k means algorithm works. Okay, so first you selected k values randomly. Let's say we selected. Okay, let's say here we selected 2. Okay, so actually my keyboard has some issues, so that's why whenever I try to write, no, sometimes it works automatically. Okay, so let's say we have already decided that we are going with k values as 2. Okay, let's say assign each data point to one of the k cluster. Okay, once you assign, so what, how k means algorithm works? First, it decides how many k centroids it has to take work. So it will, let's say, I mean, we said that we have we will work with 2 cluster. So it will just select 2 points from the data set. Okay, let's take the data set also. Okay, so what it will do, it will select 2 points randomly. Okay, any points. For example, let's say now assume this one and this one. Okay, no points from here. Okay, so now what it will do, find the distance of point from each cluster mean. Okay, now what we have to do, any point closest to this one will come to this cluster, and any point closest to this one will come to this cluster. Okay, so here since we have kept both I mean both points randomly and I mean very close to each other, so that's why you will understand that you will get to know that I mean it will take very I mean at least a good amount of time to converge. Okay, but at the end what will happen, no, your cluster, one cluster will be one cluster center will be here, and one cluster mean will be close somewhere near to here. Okay, so basically what you will do, you will take the different cluster, I mean different random points as a cluster mean, and you will calculate the distance of all the points from here and here, and like the whatever the distance, I mean the points closest cluster center will you will assign that point into that cluster center. Okay, for example here let's take this one now. I think that would be c2 identify. Let's say this is your cluster 1. I mean, yeah, first initial cluster 1 center, and this is your initial cluster 2 center. Okay, so all the point closer to this one you will assign. I mean, let's say this point is closest to this one or this one. This one, no. So you will assign it to this cluster. Now go to this point again. This is close to this one, so you will assign this cluster. Okay, let's say let's give the number that will be easy to. So here this one is cluster 1, this one is cluster 2. So all the points you will see it is closest to this one, not this one. So you assign them the cluster 2. This point is closest to this one only. So you assign cluster 2. This point is also close to this one. So you assign cluster 2. Okay, like this you will assign cluster 1, cluster 2. Okay, let's say you have one point here. So what you will do, how will you decide whether it belongs to cluster 1 or cluster 2? Anyone who would like to say?
By calculating distance from the
Right.
means.
Yeah. So basically you will calculate the distance from here and here. Let's say this one is 2, this one is 3. So it will, what will happen here also, like you will allot it into the cluster 1. So once you allot the cluster, I mean allot all points into some different cluster, then you will calculate the cluster mean again. Okay, so obviously initially this was your cluster mean, but let's say now your cluster mean will be somewhere near to here or any places. Okay, so once you will clear see, no, I mean your cluster mean will get updated. Okay, now after this again you will do the same job. Okay, now once your cluster mean has updated, again you will start from the step 2. Okay, now again you are again checking the distance between all the points, and whatever the distance is minimum, you are assigning that point into that cluster. Okay, so like this again you will repeat this step, and you will do this step until unless there are no new points like which is whose cluster center is changing. Okay, so you are going to repeat this step till that moment. Okay, so and at that moment you will say that your model has, I mean the K-means algorithm has converged. So this is the step which we do in K-means algorithm. Okay, anyone has any confusion in this or wants any clarification and any step?
So for the point which will have equal distance, where will that go?
So yeah, so it completely depends on your model. I mean, and on your, so it won't affect you. Okay, you can assign it into any cluster. Okay, in real world, what happens? No, there are very low chances of that. Okay, so because let's say here now, I mean, you have just, I mean, just one dimension. I mean, just two dimensions. Okay, but in real world cases, like you will have very high dimension. Okay, here you just had two dimensions. Okay, I mean, see, just assume. Let's say you have features, so it is nothing but your dimensions only: age, weight. Okay, age, weight, height, gender, like this. Let's say let's take the for example only. How much do you think that the one person would have all the things similar? I mean same only. I mean there would be
So
two person who,
distance
yeah,
may be same from the mean, but what I'm thinking, sir, is that total distance may remain the same because it's counting the sum, right? As
yeah,
so, even if values are different, what if sums turn out to be same? So in those cases,
yeah. So see here you are thinking that I mean all these things points to see. This is, see, you are able to see like this because I mean it is very easy to plot anything in two dimension. Okay, and here like what we are assuming that you have just two, I mean two features, age and weight. Based on that you are plotting every point. Okay, but that won't be the case, no. I mean if you have some point in some, I mean let's say here only, like let's say one person has age 55 and weight 2, weight 28, or I mean yeah, 60 kg. Okay, there are another person who has weight age 55 and weight 60 kg. Okay, there are high chances that there can be similarities if only two features are there. Let's say you have like 50 or 100 features. What will happen? Do you think, I mean all the, I mean there are high chances that two feature, I mean two rows would have the everything exactly same, And even it is there, no, see, even it is there, you can easily assign it. I mean, your algorithm will assign it to randomly into anyone. Okay, I mean, so it depends. See, again, this also depends on algorithm to algorithm. Some algorithm what it does, no. Let's say let's say like in fourth sample, it assigned to it to fourth sample, it assigned it to the, I mean, cluster one, and in the fifth sample it found that, I mean, both things have the, I mean, the both its distance from both points are same. So maybe it can then based on the previous response, it will again allot it to the C1 only. Okay, it depends randomly, it decides. Okay, and let's say one more thing, like let's say 1 lakh points you have. Okay, in real world, obviously you would have large number of points. Okay, let's say 1 lakh points you have. Obviously, every algorithm will, there will be errors. Okay, 1 lakh points, and you just let's say you, I mean, mistakenly, or I mean, maybe some is due to some issues, you allotted it into this one. I mean, the in the wrong groups. So do you I mean, just understand how much inaccuracy will be there. There will be very few inaccuracy, no? 0.00001. So that's why it doesn't matter. Okay, it depends on the algorithm. Some algorithm just based on the previous response, it allots it to that same cluster. Okay, but for your understanding, you should think it like yeah, you can randomly assign it to any cluster. Okay,
Yes,
let's
sir.
say here, yeah, yeah, someone was saying
How
something.
to first choose the centroid?
So initial centroid, see, again, for now, for alloy algorithm, there are no rules. You can choose any centroid.
So,
Okay,
like basically, if we choose any wrong, it will go like it will take many more steps to converge or
right,
anything.
right. Yeah, obviously that will happen. Okay, if you take any wrong, I mean, at least not a good initial points, no, then it will take.
To
I
resolve
mean,
that issue only we are using k means plus plus. Is it
plus
not right?
plus.
Yeah.
Right, right. Exactly. To resolve this only, like you have k-mean plus plus algorithm, which tries to resolve it. It also doesn't guarantee that your issue will be resolved, but definitely that will produce the better. I mean, that will, its computational time will be better than this k-means algorithm. Okay,
Yes,
that's
sir.
why k-means plus plus. Okay, so basically, what can happen? No, even it can also happen that you will just fall into the local optima. Okay, a local minima. Okay, so it can also happen. But again, no one is, I mean, giving guarantee for these things. Okay, what you have to do, obviously, so for these things, I mean, sensitivity to this initial points, initial centroids, only due to this, there are your algorithms performance are highly sensitive to selection of your initial centroids. That's why you have k-means plus plus, and that also doesn't and k-mean plus plus also doesn't guarantee that your problem will be solved, but you can say that it has higher chances of getting success. Okay, something like that. Understood or anything? Okay, okay, thanks. Mm, Let me delete all these things. So yeah, yeah, that is the job of k-means. Okay, let's move to the next slide. Yeah, same thing again. We have written it into the more formal way. I mean, just by writing it to the number in mathematical format. So your data points are x1, x2, dot dot x1, and these are the cluster indicators which denotes your cluster one, cluster two, cluster three. All these things are there. Okay. So here, this is the function that maps the cluster index to ith data point to the tth iteration. Okay. So all these are just mathematical notation. Okay, which professor has used. Okay, so here, I mean, see, this one just focus on this formula. Okay, obviously whatever we have said here, it is same thing. Okay, this is nothing but again we were talking, no, how to create the mean of the. Okay, how to create this, how to calculate the centroid. Let's say earlier. Okay, maybe I think I should come up with lesser number of points. It doesn't have undo button. Okay, here we haven't do. Okay, let's do it here only then. Okay. Yeah. Okay. Okay. Let's see. This is a point one. Okay. I think I should write everything here. Okay. This is 4-1. I think, yeah, 1-4. This is 2-2. Let's take it as maybe just by seeing this diagram, it looks like this is very far from here, but obviously that won't be. Okay. Let's take it 2-3. Yeah. Now it will be 3-1, 4-1. We have all these points. Okay. Let's say uh, this is your cluster, and yeah. Okay. This is your cluster center, and this is your cluster center. Okay. So how would you calculate this cluster mean? This is your mu, no? Mu1, and this is maybe mu2, right? I mean, are you clear?
Yes, sir.
Okay. So this is what we have to see. Compute means for all k clusters. Okay. So basically this formula, what this formula is going to do, it is going to calculate this cluster mean only. Okay. For mu1, it will create, it will calculate, then again, yeah, it will give the cluster mean of second cluster also. Okay. This is cluster 1, this is cluster 2. Mu1 is the cluster 1. I mean, cluster 1's mean, mu2 is cluster 2's mean. So how will you calculate this mean?
1 plus 2 by 2, comma 4 plus 3 by 2.
Right. 1 plus 2 by 2 comma 4 plus 3 by 2. Okay. Similarly here also 3 plus 4 by 2 comma 1 plus 1 by 2. Okay. Like this you will calculate the mean. Okay. And yeah, this way you got the mean of this center and mean of this center also. Exactly same thing is being represented by this formula. Can someone decode this formula? I mean, anyone? Okay, I'm just trying to interact with you guys so that I can see that whether you are active or not. I
Xi
mean,
represents the value of the data point, sir.
XI, right?
And 1 is supposed to be if the data point exists in that particular cluster, it will return 1. Otherwise, it will return 0.
Indicator function.
Right. Indicator function.
I don't know the technical word. That's
Yeah.
I think it's that one.
Yeah.
So sum of all the data points.
Okay. Sum of
all the data points are in that cluster. So it will count all the data points, add up, and divide by the number of data points.
Oh, okay, okay. I think, yeah, let me see. Add to, okay. Add to current page, maybe. Yeah. Let's see here. Okay. I'm not getting option to import that. So, okay. Yeah. So basically what it is doing, no, see the same thing. So this function, I mean, this complete part's the job is to just indicate whether it belongs to the same cluster or not. Okay. And this is the just the number of points. Okay. Here you took no. Okay. Here you took 1 plus 2 by 2. Okay. So okay, here only. Okay. Maybe yeah. Now I hope I will be put it here. No, it is not getting. Maybe Control V is not working. Okay. Anyway, just discuss it. Okay. So basically, yeah. Here, what is happening now? Let's see in this question. Here, 1 plus 2 by 2, comma 4 plus 3 by 2. This is mu1, no? Now let's take this example only. 1 plus 2 by 2, which we, okay, yeah, this one only. 1 plus 2 by 2, comma 4 plus 3 by 2. Here, we had 1 plus 2 upon 2, comma 4 plus 3 upon 2. Okay. This was your I think, yeah, this was your mu1. Okay, so here, what is the job of this one? This one is just this indicator is just to check whether that point belongs to this one, or I mean the same cluster or not. Okay, so here due to this part only, you are getting 1 and 2 here, not I mean other points like 3, 4. Okay, so this is the job of this one, so that you are summing only 1 and 2. Okay, you have to sum all the data points. So you saw that you had data points like uh, 1 comma 4, 2 comma 3, 3 comma 1, 4 comma 1. You had 4 points. Okay, and 3 and 4. You had 4 samples, and out of these 4 samples, you took first 2 samples. I mean, yeah. So this part's job was to take these first 2 samples. Okay, then only for this first 2 samples, this part will denote it as a 1, indicate it as a 1, and for the next 2 samples, it will indicate it as a 0. Okay, and for the when you will calculate mu2, at that time, for these 2 samples, this indicator will give you a value as 1, and for these 2, it will give you a value as 0. Let's not talk about mu2 for now. Like, let's talk about mu1 only. So this one, so what you have done, you have sum xi. Okay, 1 plus 2 by 2, and yeah, similarly like 4 plus 3 by 2. And now what is the job, like at the base, what is there? Like, it is just a like indicator function only. What is happening for every point? It is giving you the 1. Every point which is available in cent maybe cluster 1, it is giving you as 1. So 1 for this one, 1 for this one, 0 for this one, 0 for this one. So total sum will come as 2. So this 2 denotes that too. Okay, I think now you would have got the I mean obviously you, many of you all would be already knowing how this formula is similar to this one. Okay, I just repeated all these things. Okay,
So why is
so
one
that
written like that? I mean, why is it written in a special
it's like an indicator function. It's an indicator function that's like this only. We denote it indicator. We denote this indicator. It will give you 1 only when zi superscript t equals to k. Okay, yeah. So this is I mean, we call it as an indicator function. Okay, yeah. So that's how it works. Okay, I think, yeah. It's not getting true. Yeah, this is the highest. Okay, I had one or more option. Yeah. Okay, so that's how it works. And again, you have to reassign the points here. Argmin function you have used, so that you can take the k values. Okay, the value at which I mean the value of k where you have the minimum value of this one. This is nothing but your distance on L2 norm. Square of L2 norm. So okay, so that's why you are said you will take new mean where you have the minimum number of distance. Okay, that's how it works. Okay, obviously, will the initialization affect the final cluster? Okay, since I think we have already discussed in brief like the practical example, so that's why I think all the questions are easy to answer here. Okay, so what do you think? I mean, will the initialization affect the final cluster?
Yes.
Yes,
Yeah,
sir.
obviously, yes. You saw that. I mean, you just now we discussed, if you are based on the initial cluster, initial initialization only, uh, it depends like how much time it is going to take, and there may be cases where your algorithm may fall into the local minima cases. Okay, so our objective is to minimize this one only. Okay, so yeah, since we know that I mean our algorithm will, the initialization affects our algorithm's performance. So that's why what should be the better way to initialize the cluster means. Okay, so one of the ways is that first randomly select the cluster mean initial, and then after that give higher weightage to the farthest point. Okay, okay, and similarly choosing the tth cluster mean, give higher weightage to the farthest point from the nearest already chosen mean. Okay, so do you think it will work? Or if yes, then that is okay. If not, then why not? Or if you work it, then why it should work? So
We can give
yeah, yeah.
higher weightage and we have to take the percentage to the total.
Right. So that we have to do. But again, here it is written that, yeah, give just some weightage to the farthest point and lower weightage to the closest point. Okay. So I'm asking whether
This will work.
this will work. Okay. Okay.
Probability high,
This is K++,
high probability of.
means algorithm.
See, probability, do not bring this probability word here. Here we have written that, choosing the next cluster mean, give higher weightage to the farthest point, and give lower, and lower weightage to the closer point. Okay. Obviously, the probability will work. Okay, that's for sure. But I'm talking about the distance part only. Okay. I'm just giving some weightage to the, higher weightage to the lower point which is very close, far from the cluster mean, and lower weightage to the point which are closer to the centroid, or yeah, cluster mean. So some of you were saying the it will work, right?
Yes, sir.
Yes.
Okay. So basically, I'll just give you one example. Okay. So because yeah, obviously any people will say directly. In general it will work only, but there are cases where it won't work. Okay. I'll just take one example. So what do you think? What is going to happen? Here you have to take. Maybe I should put some extra points, some more points here. Okay. Okay. Or maybe just think it like, yeah, this is, very large size. Okay. Okay. Something like this. What do you think? What should happen here? And this is little more far from here, maybe, or at least this much is also okay. I'm doing these so that at least you get the clear idea. Okay. So this one is there. So what do you think? What is going to happen here?
Sir, it depends on how many clusters we want.
Okay. Here, obviously, see, you can see that two optimum cluster would be good. Okay, because let's say you already know. All these points group belongs to like one type of peoples are there. Let's say here, let's say you understand it that yeah, this belongs to. Let's say here their people's. Maybe age is there, and here you have got the like score. Yeah, maybe let's say yeah, score maybe, or maybe marks, that would be the okay. Yeah, let's say here you are starting from 0. Here you have got from 60, here 80, and here 100. Okay, what do you think? Would you like to divide it into two groups, two clusters, or it is good to keep them in one group and keep all these things in the one group? So what I'm trying to say, let's assume that yeah, here the best cluster would be two clusters. Okay, so how your cluster will? We were talking that it's good to take the example where where the point which is very far from one. We have to take those centers like which is very far from here and here. So cluster one will be close somewhere near to here at the beginning, and cluster two will be somewhere close to here, right? And
Yes,
at the
sir.
end, what will happen? What type of cluster you will be able to get? Like this. This one will be your cluster one, and this one will be your cluster two. Something like this. Obviously, no.
Yes.
And yeah, this would be your cluster point. Okay. So basically, what is happening? No. So you are seeing. You are. This is also one of the example where you can directly see that your distance. If you use the distance only, no, that is not going to work. So that's why basically, and if I put it in the better word, it is like if the size imbalance is there, no, cluster size imbalance is there, one cluster is very big, another cluster is very small, then this is going to create problem. Okay, if you only use the distance only, no, then it is going to create problem in those cases where your size issues are there. So, but in general, there, if the size issues, let's take that example. Someone was saying no spam mailed and non-spam mailed. Let's take like obviously if you have 1,000 spam, non-spam mailed, then only 10 or 20 spam mail will be there, right? So here if you are getting 1,000 points, then here you would have only 20 points. And in these cases you will see that if you just use the distance, no, that is not going to help you. Okay, that won't work well. Okay, ideally any algo, you no one can guarantee that which one will work well. Yeah, or chemist will work well. There is no guarantee like that. But definitely, K-mean plus plus, or if we calculate just if you use distance only, no, that is not going to work. That is not helping you in all cases. But in most of the cases, that is going to help you. And obviously, there are proportion. Good proportion. You will have to give weightage to this distance also. Obviously, that should be there. But only keeping only distance as a proportion, that is not going to help you in every cases. Okay, that's why we come up with this probability function. Okay, or we call it just proportional to the distance. Okay, it also depends on the density. Okay, so that's why some other factors should be there which which should give the weightage to these points also. Okay, while deciding which one should be your next cluster. Okay, for now, in simple words, just take it like definitely if you just take distance now, then you are going to uh, you have the size in especially in case of size imbalance, your algorithm won't work well. Okay, and so that's why k means plus plus does not use just this distance. Obviously, it is proportional to distance, but it also gives some weightage to these points. Okay, when you take this probability density, it gives some weightage to these points also. Okay, at least this example is clear or not? Here you guys agreed, no? This one is not going to work well. Not going to help. Only the distance.
Yes, sir.
Yes, sir.
Yeah.
Yes,
Okay.
Yes,
Yeah. So that's the thing. Okay. For k, yeah. Obviously, you have already answered like for k equal to 1, what will be the objective function value? So again, maybe some other person can say. Okay, I think yeah.
but not
Yeah.
clear with the last two steps in the previous slide, sir. In the second
Okay.
step, it's okay. We have to choose the next cluster as whichever the highest probability is having, we have to give the weightage. What about the again third one? So again, we have to choose the highest weightage or whichever is the closest to the previous cluster.
Okay, so what happens? No, okay. I just got your point. So what is happening? No, let's say you took this one cluster one. Okay, this one
Yes,
is
sir.
your just by giving the highest maximum distance, you chose this one as cluster two. Okay,
Yes.
let's not take this. Exception case. Okay, so now you have to decide the cluster three. Let's say you have to. So I think you are saying that you have to decide cluster three also,
Yeah.
right? Okay, so for this, you will choose for every point you will give the distance value. Let's say, and the distance value will be, let's say, from here its distance is 4, here from here its distance is 3. Then you will give the distance score as 3 for this point. Like this, you will give every point as some distance value. Okay, one point is here. Let's say here it is far from here like 5, and 4 from here. So what will be the the value here? 4 will be the value. Okay.
Okay.
Okay. Just give me one. Okay. I think, uh, okay, just give me some second. Yeah, I think. Yeah. Okay. Yeah. So that's the thing. I think. Yeah, we have discussed till here. Okay. So okay. So yeah, one question here. Let's say what will happen with your objective functions value when you would have the k equals to n. So what I'm saying that let's say you have the maximum number of clusters. What is going to happen?
The distance is 0.
0. Distance.
Right. Okay. So that's correct answer. So and obviously we have discussed that why should we not use the high value of k? Obviously it should be optimum. It should not be a very low value and it should not be the very high value. It should be optimum. So that's why what we are doing here that we are adding some penalty term into our objective function. So that which will say that yeah, obviously your error is increasing. Once you are increasing the k value, it should penalize your objective function. Okay. So yeah, and now let's. So I think yeah, the main question at the beginning also you see, and I think the biggest question with the k-means algorithm is, I mean k-means algorithm has just two issues. Okay. First thing, like what should be our initial points? To solve this, we have k-mean plus plus algorithm, which can solve it. Although it doesn't guarantee, but maybe it can solve it. Okay, I mean, yeah, at least in the most cases, it is going to help you in most of the cases. Okay, and second issue is that this one, how to select the best optimum number of k values. Okay, I mean, what should be the optimum number of cluster? That is the biggest issue with the k-means algorithm. Okay, so, and there is just one rule, I mean, which really works in real time. No, you have to iterate through the different models. I mean, just see the score. There are different metrics as I discussed. Okay. So, I mean, at the initial point, at the beginning only, I told you about no, to calculate the distance between its own. I mean, calculate the distance from any point to its own center, and also to the the centroid, like which is are the point which it belongs to some other cluster. Okay, and obviously we have some metrics like Silhouette scores are there, so which works on this only. Okay, basically by using these distances, it creates a formula, and yeah, based on that formula, it gives a score to different values. I mean, to the performance of your k-means algorithm. Okay, when you try with different k values, no, you see that score, and based on that score you can decide which k value is the best one for your model. Okay, and apart from that, this elbow method is also one of the ways, but again, as I told you, in practical, in real world, these things doesn't work. Okay, I mean, what is going to happen? No, okay, let's not go for that. I mean, the best way is this one only. You have to manually, I mean, try from, let's say, from k to 2 to, let's say, 20. Usually what ideally we do, no, let's say if you have 100 samples, no, you will go with the up to 10, and like under root of 100, like this only we work. Let's say you have, like, let's say 500 samples, then under root of 500 you will work till that work. Okay, and you will iterate through all the models. You will try every number of samples, like every number of k values, 2, 3, 4, 5, 6, like this, up to k, up to root k, root n, sorry. Yeah, okay. Okay, that's how real world works. Real world data set works. Okay, but if we talk about the theory part, I mean, at least this elbow method, people see these things will work only when your data set has, I mean, small number of samples, let's say 4 or 5 samples or something like that. I mean, your data set is simple. It is easily classified. I mean, it is very easy to classify. I mean, those type of data set you have, then these methods are going to work. Okay, I mean, there are you can easily separate it. Then these methods are going to work. Otherwise, it is not going to work. For example, let's say we talked about that grade. No, let's say your data set already has that column, which is called as grade. Okay, 1, 2, 3, 4, 5, 6. I mean, yeah, uh, grade S, A, B, C, D, E. Let's say your data set already has these things as an input, and you trained your model. So in these type of data set, you will see no. I mean, you can see clear elbow. Maybe you can see clear elbow. Something like this will happen. Okay, you will see how many point 3, 4, 5, 6. Okay, at 6 you will see this clear this elbow. Okay, I think here currently there are 2 elbows for now. Okay, I mean in this graph, but you will see I mean clear turning point. Okay, for this type of graph we call it as the elbow. Okay, you just see the shape. Okay, the shape will be something like this. I mean this elbow shape is there, no? Okay, so that's why, and this critical point we call it as I mean elbow, and this one elbow method says this only, that this one we take it as a I mean optimum value of k. Okay, but see, I mean, in ideal cases, we are seeing here that this is the elbow point. But in real world, when you see no, I mean, what you are going to observe no, there are multiple points which where you will see this I mean slope drop. What is the I mean biggest thing to see here? No, there are I mean very high amount of I mean change in slope. Okay, so let's say this example. Okay, in real world, you are going to see some examples like this. So what you are going to do here, let's say this one is your k equal to 5. This one is k equal to 20. This one is k equal to 50. Okay. So now which one would you take? Let's take an example of this one. This is your k
5,
value.
sir.
Okay,
5.
5. Yeah, okay, 5 you took. Some other person?
It will be 50, I think.
50. Okay, any other person would like to say anything?
50.
50. Okay, what about others? I mean, yeah, we have few people like, I mean, one person who said 5. There are person who said 50.
5.
And yeah, 2% for 5. Okay. No one is for 20, is it?
No, because you told that the maximum drop, the curve wherever it takes, the change that with that
Yeah.
principle.
Yes, the deep saturation, immediately it starts to, the
Yeah.
trend changes. Where the trend
Okay.
changes.
Yeah. So again, if I talk about the real world cases, so here, especially in machine learning, no, there are no, I mean, hard and fast rules. Okay. It completely depends on you. You have to choose the k values. Yeah. It is just that you have to see what will happen. If you see, yes, see, one thing is for sure here. If someone is taking k value as 5 and someone is taking k value as 50, person who is taking k value as 50, no, their model will perform well. I mean, perform better. Okay. I mean, are you getting my point? I mean, why? The reason is very clear. Yeah, maybe it may overfit also. What is happening? No, I mean, let's say you have three. Let's say you earlier you had just 5 grades. Okay, and now what you are doing? You are creating cluster. Maybe for every 2 points, you are creating one other group. Okay, for every here only like no marks will be like 0 to 100. No, for every grade you have 10 points. Okay, and now what is happening now, let's say if someone is creating 50 groups, then like one or two marks who have 1 and 2, they belongs to group 1. And let's say let's go from 10, 98 to 100, 99 to 100. This person, I mean the people who have got 99 and who have got 100, it belongs to another group. 97, 98, this belongs to obviously if we group like this, no, obviously there, I mean, it is going to perform better, no? I mean, at least you see here, I mean, these two people are there are see, one person got 99, one person got 100. Okay, so obviously here, I mean, so whoever has took 5, they are saying that let's say you have 50 and 90. So one person has 90, one person is 50, and another person is. So these people and one person, let's say 30. So you will say that this person belongs to this group and this person belongs to this group. Like people who took this 5. Okay, but what if I mean, as the same thing will this will also say. Okay, but what will happen if one person has 90 marks and one person has 92 marks? Then the people like who took 5 k equal to 5, they will say that both belongs to the same group. But people who took 50 samples, okay, I mean 50 k values, they will say that now this 99, this 90 people belongs to this group, 99, 1, I think, yeah, 89 and 90 group, and person who this who got 92, it belongs to that group where 91 and 92 is there. Okay, so basically see all the issues you will see here only. Okay, so what is happening here? Are you guys getting, or I mean something random or something alien I am saying?
No, the point here is how this quite correlated to elbow method, because in a picture you have depicted, say, at 5 and 20 and 50. In this context, we are not picked up the.
Okay, yeah, I got your point. Okay, yeah.
Then I think we are not getting it. But
okay.
Pictorially representing, then we know that like which one we should take. Like, is it like now by grouping is the mechanism you have mentioned. The smallest is the groups. I think the best, because probably mean etc. could be different, and you say that's better. But that is not correlating well with the elbow method.
Okay. So yeah, both things I'll say here. Okay. So first thing is that, I mean, see what I'm trying to say here. Let's say for this marks part only. Okay. Our data set is the marks. Our data set is the marks of people. Okay, marks of people. Okay, like which is distributed from 0 to 100. Person who took that, they will take k equal to 5, means they will create a 5 cluster, right? So what we are assuming that this 5 cluster will be something like this, and obviously k-means will what k-means is going to do. It will keep 0 to 20 in one group, 20 to 40 in another group, 40 to 60, 60 to 80. I mean, yeah, 61 to 80, and 81 to 100. Okay, like this, the people who took k equal to 50, k equal to 50, k equal to 5 means 5 groups, right?
Correct.
And 5 group means like this, right? And that's how you will you are going to decide these people.
Yes, sir.
Okay. Now the person who took k equal to 50, practically he is saying that he is going to create 50 groups. Okay. So each group will carry I mean 2 type of people, no? First group like people who got 0 and 0 or 1. Second group will see 2 or 3. Okay, like this 50 groups he is going to create.
Yep.
Okay, so this is what I was trying to explain here. Okay, now what is going to, so see which one is better. For that I was taking one example, that let's say you had two so I mean which algorithm is better. I mean that you will see currently all the data set you already have. It depends on the new data set. I mean how well your model, or I mean your algorithm is working for new points, right?
Yes, sir, that's my concern. Like it will depend upon the number of data points also, like how many clusters we want to justify the groups as well.
Here, okay, for example, here we had 100 points. Okay, let's take this example only. We had maybe, or I think I should not take C the like 1,000 data points. Okay, or any data points we have. Let's say 1,000 students are there, and their marks will be distributed from 0 to 100, right?
So
okay,
but as you are taking the marks case here, but we can see like in the mark case scenario, 5 clusters will be sufficient to decide. I mean, but as you were taking the movie
Yeah,
recommendation.
I understood. Right. I understood your points. Okay. So again, this is what I mean. Again, as I told you, here nothing is first. I told you 2 points. No, here nothing is correct, nothing is wrong. Everything is relative. So people who are taking, okay, you are coming to my point only. So I was just by this way, I was just giving you example so that I can show you the real issues. Okay. First point, you saw that how many samples you have and how much complicated data you have. Okay, samples or complexity of your data set. Okay, complexity of your data set. Let's come to the real world problem. See, what is one thing is for sure. If you take k equal to 5, no, if you take k equal to 5, then your and someone is taking k equal to 50, no, their training time is going to very high. I mean, at least if I compare it to the people like who took k equal to 5. Here, let's say lower computation time and cost. And for now, obviously, let's assume that let's say you have very good amount of, I mean, very high amount of samples. Okay, and your data set is highly complex. Okay, let's for now just take it like that. Okay, lower computation time and cost, but data set has a high complexity. So what is going to happen? Okay, so for that case, I think both will work. Okay, so this is the issue. Okay, first issue is this one, but for k equal to 50, higher computation time and cost also.
Yes, sir.
Okay, so higher computation time and cost, although it is giving you the better result, but still it is, I mean, you have this computation cost, your time. Okay, and it is also taking higher amount of time. Okay, because the biggest issue with this scheme is, no, I mean, these algorithms every time it is not a pre-trained model. Every time once you get there some new data points, it will again go to, again create cluster and assign this point to some cluster. Okay. So what I am saying, no, let's say you have 1,000 samples. Okay, and you have already created group cluster. Okay, 5 cluster or 6 cluster. Once I give you the another 1 point, no, it is not like you will directly assign it to some of the cluster. Again, it is going to create, I mean, do all these calculations. Okay, or at least maybe this point, 1 point, it will calculate its distance from each cluster. Okay, and it will assign that that point into that cluster. Okay, and let's say someone has this, I mean, 50 cluster. So it is going to create its distance from all the 50 cluster. Okay, every time it will have to do this calculation. Okay,
So
and for other, yeah.
Every point, for example, in the case of k is equal to 5, all the 100 points for each of the 5 groups they need to have. So 5 into 100, 500. Whereas in the second case, 50 into 100, for example, 5,000. Whether that's a kind of computing costs that we're talking about in terms of calculations?
Yeah, so both can happen. So sometime what happens? No, in some cases we just calculate the distance from its cluster mean, and sometime what we do, we calculate all the distance, like you said. No, I mean, from all the data points. Okay, because it may happen that due to this new point, this cluster center itself may change. Okay.
I assumed a cluster center, sir. That's the reason I used 50 into 100. I did not say 100 into 100.
Okay.
If in the first case I took 5 cluster centers are there and remaining 100 points are there. That's how I assumed.
Okay.
Maybe of course you maybe other group you try to compute with the other cluster centers. So numbers may slightly change, but approximately I told, sir.
Okay, so one thing is for sure that what you understood here, your critical points. See, first thing is that here you saw that these are the critical points 5, 20, and 50, and it depends on you. I mean, how much, whether you are okay with this computation time. Let's say you say that here you got the like, I mean, it took like 5 minutes to train the model. Here it took somewhere near to 7 minutes, and you are happy with it. Then obviously you can go for 50. But let's say sometime what will happen here, you took 5 minutes and here it is taking like a 4 hour or 3 hour. Okay, then will you go for this? Obviously not. Okay, so that's why I'm saying it completely depends on you. Okay, and the particular data set. Okay, how data set form. So that's the first case. And second case, like which I didn't talk here, is the complexity of your data set. Okay, if your data set is not highly complex, no, then in that, see, if your data set is complex, then this, I mean, this one is sufficient condition to decide. But if your data set is not highly complex, no, in those cases, if you select the higher number of, I mean, samples, a higher number of cluster, no, then you are just trying to overfit it. For example, the example we took, no, I mean, the number of students, wala, huh? I mean, the number of students, like 1,000 students. In these type of cases, if you go with this higher value of, I mean, higher value of k, no, I mean, at least this much higher, 50. So then you are trying to overfit it. Okay, then in those type of cases, it's I mean, it is highly recommendable that you just go with this k value. Okay.
Yeah, sir, you also suggested that approximately this case you can, an example, you suggested the root n. In this case, root of 1000 you take maybe 33 or something, it will come. It will not be above 33 is more
right
computing intensive, whereas anything less than 33 based on this one is kind of less computing intensive.
Right. So no, it is not like ideally in general we practice this. Okay, in general we practice. We don't calculate. So I mean, there will be another proof because like if you go with more than this 33, no, I mean the value of 33, then you are unnecessarily doing some. I mean, you are trying to overfit it. It is like that. Okay, so that's why you should not go any value. I mean, you should not try a value more than 33 for if your sample number of samples are 1,000 only. Okay. So that's the thing. Okay, so these are the issues and these are the real world cases. Okay, but in pictures or in, I mean, samples, you will see that how elbow method works. You are going to get this and you are going to get this. You are going to get this type of shape. Okay, but that's not how real world works. Here you are clearly, you are able to see this, I mean, elbow. Okay, but that's not real world works. So that's what I'm saying. So ideally we try the best thing which we, I mean, usually we do in a practical, no, we iterate. Okay, that's the only thing to, I mean, see the cluster to decide the number of cluster. Okay, so yeah, that's about the, I mean, elbow. At least this is the elbow method. So yeah, let's leave it the practical part. The basically elbow method says this only, that where this I mean, the you would see the highest amount of this change. I mean slope change. Okay, so that point you have to take as your optimum value of k. Okay, so this is what elbow method says. Let's look at the, okay, and yeah, obviously nature of clusters and everything. I think let's convergence part. Let's discuss it tomorrow. I mean that I mean not tomorrow, Sunday, because this Sunday. I mean, what do you think? I mean, should I discuss? I mean, this theory part only, or maybe I should discuss problems, because what we are thinking. No, yeah. Someone was saying something.
Yeah, sir, we need to discuss maybe some problems also, some examples of PA or something like GA, because it's becoming more complex to understand and calculate.
Right.
Yes, sir. Yes, sir.
See, this is one of the okay, we can do that.
Some previous questions also, sir.
Yeah. So
if you solve some previous questions also, it will be
okay. So what we are planning, no, at least our TAs will discuss that. TA is going to discuss these questions. Okay. So
okay, sir.
Yeah, so definitely, I mean, for first 2 weeks, I think, I mean, many of you were requesting for more number of questions. So we are also planning this only, like maybe some previous papers. I mean, we will just, we use the previous papers question, and that we are going to discuss. Okay, so we have asked our TAs to create the sets of questions. I mean, just to, I mean, bring all those questions in once at one common point. And maybe after that, once since just yesterday or day before yesterday we have said them, so they will come up with these things. And once they will come up with these things, we are going to discuss that. Okay. So see, these K-means algorithm, these are just the basic thing. I mean, again, as I told you, I mean, these are at least if you see the mathematical. So here, I mean, in maybe in lecture, it may look like this is little difficult. I mean, this is a complex topic, but it is not. as you saw, I mean, maybe just due to the mathematical topics, it is looking like that. But otherwise, yeah, if you see in the real world, if you compare it with some real world examples, I mean, it is a very fairly simple topic where you are doing just nothing but, I mean, just you are creating clusters just by calculating the distances, nothing more than that. Okay. Hello.
Yes, sir. We are hearing.
Yeah. Okay, so that's about this k-means clustering. Okay, so maybe yeah, if you guys think like that, then in next session we will discuss practice assignment and this convergence part. Okay,
Okay,
is
sir.
it okay? Yeah,
Yes,
and
sir.
after that, like yeah, once our TA creates those sheets, no, then maybe we will discuss that also. I mean, maybe either we or our TAs will discuss that. Okay.
Okay, sir.
So the session will happen. And if you guys want that also to be recorded, then yeah, whoever joins the session, just ask the TA to record it. Okay. Or otherwise, yeah, we can also say them to record it. Okay.
Sir, if we ask them, they told that they are not permitted to record. It seems, sir.
Is it?
Usually, the TA sessions will not record it. Yesterday, one session was happened, sir. At the time, we were
Okay.
requesting, but the TS told like that only.
Sir,
They're
that
not
is actually
supposed to
very much
record.
required. We are working professionals. Today, luckily, I
Right,
had
right.
meetings.
Correct, sir. Exactly.
Otherwise, very, very difficult for working professionals, sir.
Okay. So then we can start. I mean, yeah, definitely we can do that. Okay.
Okay, sir.
Particularly those sessions where they are going to discuss questions. Okay. So currently, what we are assuming, no, I mean, these questions are needed to be discussed. So either two things can happen. Either we will take those sessions. Okay. Otherwise, if TA will do that session, a TA will take that session. Then yeah, he is going to record it. It depends on the like how much concepts are there. For example, this week, I mean, see, this week is relatively. I mean, we have relative lesser density for in week 3. So that's why we will have enough time to discuss questions in next session. But
Okay,
in
sir.
some weeks, okay. But in some week, if we don't have the, I mean, enough time, no, then yeah, TA will discuss it. Okay, and since already 3 weeks are gone, so maybe we will ask TAs only to discuss the questions for first 3 weeks. Okay, and yeah, we will do the recording. I mean, no need to worry about that. Okay.
Sure.
Okay.
Thank you so much.
Okay. Okay, welcome. Anything else or any clarification you guys need?
Sir,
Clear,
where
sir.
we can
Nothing.
get
So
all
shall I leave,
the
sir?
links, sir? Old links, recorded links? We are not able to see it.
For this term's recording or what?
This term, sir. Only for this term, not the previous.
Okay, September term. Okay. In YouTube, if you go, okay, I think Prasant. Okay, I'll just give you the link. Okay, yeah, Prasant. Prasant is saying something. So what had happened? No, I mean,
Sir, is
see,
it
first, yeah. Just let me complete. Okay, then yeah, you can start. Okay, so what I was saying, so for first two sessions, I mean not first two sessions, every week's first Friday session, I mean week one's Friday session, week two's Friday session. What had happened? No, we were seeing the options of like start streaming. Okay, by default we were getting the option. So we clicked on that option, and basically what that option was doing, no, it was just streaming, but that streaming was not getting uploaded on YouTube.
Understood, sir.
Okay. Yeah. So that's why we missed to record. I mean, we missed to stream it on YouTube. First two sessions. I mean, yeah, Friday session of week 1 and week 2. But second session of week 1 and week 2, we were. I mean, we did that. So that's why it is there on the YouTube. And this is the. I think this would be the. Yeah, this will be the third session which will be there on the YouTube. Okay.
Sir, one
So first, yeah.
Because I
Yeah,
know that January term, probably previous term and current term, like kind of same syllabus. We are in a new syllabus. So in case, more or less, I think sessions are similar. We can get at least old links mapped to the current term, because very difficult to go and understand live sessions of previous term and try to match. If there is a alignment, there's a little bit too much to ask, because otherwise the people definitely will miss out, sir. I typically participate less than 20% of sessions. Luckily, I had time till 8 o'clock for my next meeting, so I was able to join today. Otherwise, very, very difficult during the daytime, sir.
Yeah. See, so whatever you guys need, no, at least inform us. Okay. I mean, if we get to know, see, now we have more power. Why? we have TAs to work. I mean, so what used to happen? No, see, for me, if you ask me, I mean, I am also taking. I mean, also in charge of this MLP project. So
sir.
what happens? No, yeah. So what happens? No, there also like we. I mean, at least in project part, no, there are a lot of queries like we get day-to-day basis. Okay, for that, I think sometime our time gets. I mean, we also do not have enough time to do something new or something extra. Okay, but now since we have TAs, then we have options. So
Yeah.
okay, so whatever some extra, so it is so now it's the case that it is not necessary to bring to. I mean, it is not necessary to that always we will take the decision. TAs are also there. If we instruct them, they are good enough. Okay, at least for to discuss these questions or anything. Okay, so we can take help of them. Okay, or even if they create the slides, no, then also like our at least 80% works is already done. Okay, then we have to just devote like let's say like 2 hours of session, then maybe 3 hours we have to devote, because like 1 hour we will see like what our questions are there, and yeah, 2 hours for the session. Okay, like that. But earlier what used to happen, no, for to create that slide again we had to put significant amount of time, and that's why I mean it was difficult. But now we don't have that issue. Okay, so basically we have already taken the point, your points. Like yeah, we will discuss this thing. I mean some extra questions, and regarding the recordings, yeah, we are. I mean now you won't see the any issues of related to recordings. Obviously, everything every week is going to be recorded, and yeah, TA session that will be also recorded. At especially those sessions where they are going to discuss the questions. Okay,
So,
at
do
least
we
the
do
record.
any
Yeah,
mock tests, sir, before the quiz one?
yeah, there will be.
Okay, sir. Sir, shall I leave, sir? Is it?
Yeah. I think yeah, we have already discussed everything. Anyone has any questions or anything?
Thank you, sir.
Okay,
Thank you,
welcome.
sir.
Okay, welcome.
So
So
next
next,
tomorrow morning,
yeah,
sir.